All right, so this is number 8, GoingNative 8. And man, unfortunately, Diego's not with me. So now I'm starting to feel like STL. I don't know how he does it, talking to a camera and no one else around. Very strange. Rock and roll, STL. Who, speaking of, will be doing a new series on core C++, airing on Channel 9 in the next few months. So that's going to rock and roll. This episode is mainly going to be about a project called Casablanca, which is basically libraries for C++ developers, client and server. Really very nice. So now at Build, you learn, not Build, but at GoingNative, you learned about the need for more general purpose libraries. Well, this is the beginning. You're going to be able to write HTTP clients very simply. At least a heck of a lot easier than you are today in C++. Interoperating with JSON in C++, REST in C++, blah, blah, blah. Lots of nice general purpose facilities for modern programming and modern C++. So kudos to that team. You're going to meet 2 of the key members. I'm going to interview them. We're going to talk about what the libraries do, the thinking behind it. And you're going to click on a link right around there and download it and start playing with it because they want your feedback. It's a Dev Labs project, which means it's all about incubation. So without further ado, Casablanca time. All right, we are in parallel platform and computing world. You guys are now part of the C++ team.
Yep, that's correct.
You look familiar, Nicholas. We haven't had you on C9 for a while. Introduce yourself.
Yeah, so I'm Nicholas Gustafsson. I'm now a program manager in the C++ team. I've been involved with the concurrency runtime team for 6 years now or so. I was architect on the concurrency runtime when it first came out in Visual Studio 2010. I have had some projects that have been more of incubation projects going on. One was called Axum that we talked a lot about on Channel 9. And that one went well in many ways. It didn't turn it into a product, but ideas from it went into other efforts that have shipped or are shipping. And right now I'm involved with another incubation project which we call Casablanca, which is all about native code and cloud. And we'll talk more about that in just a second, I guess.
Excellent. And
I'm Steve Gates. I'm a tester on the C++ team, and I've been working with Nicholas and a lot of people in this group for a little while now. My background is working on Concert before in Dev 10 and helping out on various prototyping efforts throughout the next release of Visual Studio, including some of the stuff on Concert, and now working on Casablanca, C++.
Cool. And so Bill Gates is your uncle, your father, what?
I have an uncle, Bill Gates, but not the right one.
Yeah. Right on. So number 1, it's great that we're seeing innovation in the C++ space in the cloud. Can you tell us what is Casablanca?
So Casablanca is several things. Basically, the core issue that we're trying to address is that there's right now very little supported functionality for you if you want to do native development for distributed computing in general and for the cloud in particular. And what I mean by very little is that the APIs that exist and the libraries that exist are often C APIs rather than C++ APIs. And we have this modern language with C++ 11, and it has all these capabilities that are not necessarily leveraged in existing libraries, and that means that developer productivity is not where it could be. Mm-hmm. And so we see, particularly since library efforts in other languages, such as C#, for example, and Visual Basic, have advanced greatly. We've sort of not kept up pace in C++, and so we're trying to address that. Now, when I said it's several things, means that to address that, we need to look at several aspects. There's how do we get access to REST services, for example, from native clients. This is going to be a big deal in with Windows 8 Metro, where native code is really taking a prominent place for client development. The other aspect is, how do you write a REST service in native code if you want to really take advantage of the sort of the high efficiency of native code also on the server side? How do you write that in C++? And then once we figure those two things out, then it comes down to code patterns and how do you write scalable code in the cloud? How do you write code on the client side that doesn't hang the GUI thread and so on? So it all comes down to how do we handle asynchrony, and do we do it in a way that is, follows the principles of sort of the modern C++ patterns, or do we do it in some sort of legacy fashion or ad hoc fashion? And we're looking at all those problems, as well as the last issue, the last thing we're taking a look at, which is once you're programming in the cloud, you have a way of dealing with asynchrony. You have tooling around native code in the cloud. How do you reason about programs that could scale from a single machine to many, many machines, and how without having to rewrite it? So we're looking at the same type of programming model that we were looking at with Axum a few years back, which is the actors-based programming model. And this time around, we're taking more of a direct library approach rather than a language approach to it. And the inspiration for that aspect of Casablanca is Erlang, which is a programming language that is not exactly obscure. It's not one of the most used programming languages, but it's far from rare. It's been used for some really large projects in the industry. So that's what Casablanca is.
Okay. And so, Steve, what is your role on this project?
Well, I would say working on a lot of different things. This is an incubation effort, so all of us involved in the project on some level are responsible for doing development, testing, speccing. But I would say a large part, most of my focus has been on kind of giving overall guidance and advising on what we need to do for our testing strategy and quality for Casablanca as a whole, and then a large part for owning and developing, in particular, our REST libraries, some of our tooling, and libraries for working with Azure, for C++ and Azure. That's mainly what my focus has been on. Nicholas has been working on some, he's more responsible for all the actors stuff. We have some streaming APIs that he's been taking on, and then we have a lot of stuff in Casablanca.
Yeah, tell us a little bit about where do actors come in? So what's going on here?
Okay, so should I draw like a diagram here and stuff? Yeah. So at the basis, the foundation of all of this is Windows, both 7 and 8. Now, the fact that that's the foundation for Casablanca doesn't mean that what we're doing can't be put on other platforms too. Phone platforms, Mac OS and Linux and so on and so forth. In fact, we're operating under the principle that what we're designing here should not necessarily, from an API perspective, be tied to Windows in any way. It should be something that can be ported to other libraries. We're not going to do that, other operating systems. We're not going to do that as part of Casablanca, but we're designing with that principle in mind.
Great.
Now then we have some, Windows, some, MS libraries such as, PPL. We talked about this earlier. This is part of Concert, right? In Visual Studio 2010, we're extending it with this asynchronous task concept in the next version of Visual Studio, and we call that tasks. And on these two foundations, we then build a number of networking libraries. So in distributed computing, of course, networking is the foundation, right? So we have HTTP, extremely important protocol. REST services are essentially synonymous with HTTP, right? If you're writing REST services, which is what the type of services that we're focusing on with Casablanca, you need some good HTTP libraries. But oftentimes, once you're sort of done with the simple patterns that REST gives you, and you have more advanced applications, maybe it's a phone that's doing some serious communication with a server, you need to also be able to drop down to TCP and do some low-level communication. An emerging standard is WebSockets, which is a sort of exciting ability to start out in HTTP and then kind of drop down to TCP in a trusted way. That is something that we're looking at. We're not, in the DevLabs release here in April, we're not going to be shipping support for WebSockets, but it's something that we've planned and are designing in here. And then UDP is another low-level technology for multicasting that we intend to support, also not going to be available in the first release. Now, on top of this, we're building, once you communicate, at these layers, you're only really sending bytes, right? So very, very unformatted data. So you need to have a higher level view of your data, not just your communication. And so JSON is a format that we have that really has become the de facto standard for REST services exchanging data textually nowadays. Obviously, XML is another important textual format. And then there's binary serialization, which is also important, particularly when you're trying to be careful about bandwidth. Sending text-based representations is highly inefficient, of course, but because the bit density is very low. But it is human readable, it is universally accepted and understood, and it's more versional, less sensitive to version issues than binary data. But binary data is important when you have, particularly when you have tightly coupled systems, like you have a device and you have your own private service that the device talks to. Binary data is realistic to use there. Now, the other thing is once you have services that are, and you've addressed sort of the asynchronous need, the need for all these things to be asynchronous, which is one of the premises of Casablanca, you also need other forms of I/O and other forms of sort of services that you rely on for these types of applications to also have asynchronous APIs. For example, file I/O. If you have a web service that accesses data on disk, and you want to sort of compose requests with file I/O, requests, reads and writes to disk, then you want all of that to work in a asynchronous mode. And Windows has tremendously efficient support for asynchronous operations, but we don't have anything in standard modern C++ that does that. So we're inventing some APIs there. And then there are other things here that are less important, things like timers, and it's always important to be able to time out. Around this, we're sort of building some hosting pieces. So we have an IIS host that can go on Azure. We have a Win7 host, which can also go on Azure. IIS is a great environment to operate in, but it sometimes is overkill for what you need, and just running sort of directly on the OS is running your service directly without any type of richer runtime around it is sufficient. And if you notice that we say /Azure, what that means is that what we're building with Casablanca should work just fine on Azure, and it should work just fine on your on-premise servers. Mm-hmm. The code that you're writing, which is here in the middle, is the same whether you're in Azure or on-premise. Now, obviously, there are some things that you may be taking advantage of that in Azure that don't exist on-premise. But the sort of the bulk of your logic isn't supposed to have to change. And here we call this box here apps and libraries. And so this is where your code sort of sits enveloped by all these things. And one library that we're building is to access Azure storage. Azure storage is an incredibly important aspect of Azure. There's not just, sometimes we think of the cloud as you're running code in the cloud, or you're running your services in the cloud, but the cloud is also about storing your data there, and getting the replication and the management and the backup and all that stuff for your data. So even if you don't run a single cycle of CPU in Azure with this stuff, you may still be storing your data in Azure. And so we need to let you access that. There are other libraries that you can imagine building here. One library that we're building is this thing we call C++ actors. And that's the thing that's inspired by Erlang, and which is meant to give you a scalable programming model, a way of reasoning around programs that can run just as well in a single box in memory as it can on several hundred boxes, perhaps.
Okay. So take us through a little bit, give us a little refresher on what an actor is.
Okay.
For those C++ guys out there who definitely probably aren't also Erlang programmers.
Right, yes.
What is the actor model?
So the actor model is, and the very name actor suggests that sort of the concept is somewhat anthropomorphic. In other words, you view things, and the designer of Erlang said that in the real world, people don't share memory. They talk with each other using messages. In other words, they communicate via, they communicate verbally, or they communicate in written form, or whatever it is. But they don't, use semaphores and locks and internal memory sharing. Right? That's not. That's not how the real world works. And in the real world, things fail. That's a very important aspect of how things really work. And that's true for distributed systems too. One of the most important differences between a single process application and a multi-process application is that you could have partial failure. In other words, one part stays up and the other one crashes. Right? So things happen all the time. And you have to account for that in your programming model. So actors the idea is that you consider these boxes. Let's just call them an actor. In Erlang, they're called processes, but processes is a very overloaded term. So the underlying model is called the actor model, and we call them actors in Casablanca. So an actor it's in many ways is like a thread, but it's much more contained than a thread. An actor cannot, unlike threads, which can see each other's memory and they can take locks and they can, do all those things. Actors cannot. They can only see their own internal state. That's it. And if they want to communicate, or they want to share some information with other actors, they have to send messages to the other actors. They have to have an identity. So in other words, they have to be introduced, if you will, and only then can they do so. So they know who they're exchanging information with. And you can now communicate in all kinds of crazy patterns. Messages in this model are all fire and forget messages. In other words, you send a message and that's the last you ever hear of that message. In the REST model, you have it's a request response. I send a request, and I can count on, unless there's some sort of failure in the system, I can count on a response. In the actor model, there's no such thing. Everything is just fire and forget. You send a message, and then you go back waiting for a message, which may be a response, in effect, but it's nothing in the model itself that says that the next message is going to be a response. So actors typically have this loop that they find themselves in, where you constantly look for a message, and you can be filtering. So in different stages of your execution, you may be looking for some messages, and in other stages, other messages. But you typically are looking for messages, and you're reacting to them. But you're making all the decisions about what to do locally. So in a nutshell, that's the actor model. It's very simple. It's simple in concept, but of course, the patterns that arise from having to do, coordination or correlation of messages without having request-response type of support makes it a little bit more complex. So one of the things that we've added in the library that we call C++ actors is we felt that request response is such an incredibly important pattern for message exchanges that we actually added library support for that particular pattern. Now, underneath, it's still a fire and forget system. But in Erlang, for example, when you want to do a request reply, what you do is you stuff your own identity in a message and send to the other guy. And you say, here's my identity, and maybe here's some message ID that I concocted. And please send me your response. So I gave you my identity, so send the response to this identity and put this correlation ID in the message too, along with the data. So that's kind of ad hoc correlation of messages. That's the kind of stuff we can do for you, and we do, right? So request response is an important subpattern that we add to the model, but we don't remove any of the efficiency of the fire and forget model. The issue typically with request reply is that you're holding resources while you're waiting for the reply, and oftentimes in a desire to optimize, when that's your only pattern, you actually hold those resources in memory, and that can lead to scalability issues. When all you really have underneath is a fire and forget, the correlation can be done for you, but you're not really using request reply at the lower level. So we free up resources while we're waiting for requests and so on and so forth. Anyway, that's sort of quickly going rat holing in a particular little aspect here.
Well, I mean, it's important because obviously this is clearly very important for isolation.
Yes.
This is a non-shared memory system.
Yes.
And that's one of the if you're going to build parallel systems, concurrent systems, right?
Yes, absolutely. And it's actually interesting. You talked about move semantics earlier, and move semantics help tremendously. And I want to actually go into that because one of the challenges in memory model or concurrency models that are not relying on shared memory is the efficiency of it. Because when you exchange data by message passing, there are really three major ways of scaling that model down into the local memory. Right? The concern is not in the distributed, because message passing is what distributed systems do. So message passing is very efficient in distributed systems, but it's not necessarily so efficient in local memory. Now, whereas shared memory has a scale up and out issue, particular scale out issue in that you don't have shared memory when you're on two machines. Message passing has a scale down issue in that you have an efficiency issue when you do have shared memory. Okay, so how does move semantics help here? When you're doing message passing in a local process, there are typically three ways of sending messages. You can copy the whole message, and you can imagine the implications of that. That is, in fact, part of the inefficiency issue that we have in local memory. The second one is you can deal only in immutable data. And this is one thing, that's, for example, what Erlang does. All data in Erlang is immutable. It's a functional language, and you can never change data. Well, if you can't change data, you never have any read-write data races. So, therefore, you're safe, and you can pass pointers to data around, because nobody's ever going to change the data that you're sending pointers to. So that can be much, much more efficient. Now but with C++ is definitely not a immutable data language. It is and it's not functional. It's, pointers you can go crazy with pointers and such, right? Now, the third way is ownership transfer of data. This is where I'm giving you a pointer, but I'm giving up all knowledge of that pointer and any interior pointers in the data structure that it refers to. So once I've sent you a message, one actor sending another actor a message, I can no longer access the data. I've given up ownership of that. And this is where move semantics come in. In languages without move semantics, it's actually quite tricky. We had this issue in Axum where we were built on .NET, where the fundamental object model is references, where there's no ownership transfer. Well, in C++ with move semantics, when you send data and you use moves to do the send, then the sender has given up the copy of the data that he had. And so we're relying on that in the design of the library everywhere we can.
Great. So Steve, pointing the camera at you now, man. Take us through some of the scenarios here, and you test the stuff, you implement some of the stuff. So give me a scenario.
Well, so we've got a lot of stuff in Casablanca. I mean, we've got a lot of. That was just like a deep dive into one portion of just the actors, and there's a lot of things you can do there. We've also got several other pieces, things dealing with file I/O, streaming, things like that. Then we've got all the integration with IaaS and Azure, and then we've got all the sort of networking libraries and libraries for dealing with REST-style APIs. So let's just take like HTTP for an example. Our HTTP library. I mean, we've got quite a few different scenarios. So one theme across all of our libraries is, it's going to be a modern C++ library. We're thinking about, wherever applicable, asynchrony is thought from the beginning. So all of our APIs expose asynchronous PPL tasks. People who are familiar with using those will get, you'll probably enjoy using these libraries a lot. And a big part is, we're presenting a library interface that, our implementation might be specific to Windows, but there's no reason why we couldn't have an implementation on Linux or something like that. So it's definitely kind of from the ground up what we're thinking about when we're creating libraries. Now, so going back to the HTTP libraries, talking on the server side, there's quite a few scenarios. So we have, using the same code for our HTTP server libraries, you can host on your own machine, just inside your own process, kind of dealing with everything yourself, or you can take the same code and you can host on-premise and IaaS on your machine, or you can even then take the same code again and host in Azure in a web role. So we've definitely got quite a lot of different scenarios to cover, especially from a testing aspect. We also have support inside VS, a wizard for helping you to integrate and build solutions in Azure and C++. And that's not just specific to HTTP in the web role. That's also to help out in the worker role case. Say you wanted to create an Azure application using actors. We have a wizard for helping you out creating stuff like that as well.
That's great.
Yeah.
So now, but the other thing, that's important. The ability, so you can already use C++ in Azure today. I mean, this isn't like, wow, we can now use C++ in Azure. But it's really about modern C++ libraries that make sense in modern contexts. HTTP, REST, JSON.
But I thought, Steve, you touched on PPL tasks, and we talk about this a lot, because a great focus of Casablanca is on writing asynchronous services, writing asynchronous code on the client because of the inherent scalability benefits of that. And maybe you should just show on the board what PPL tasks look like, because we haven't really.
Has there not been
really shown that.
No Channel 9 videos on PPL tasks?
I
sense those will be coming pretty
but
soon.
it may be useful to get it in context anyway.
Yes.
Yeah. So coming in Dev 11, this is from on the concert team. They're creating similar to how in .NET and C# you have the idea of task-based programming. There's also going to be tasks in C++ now in PPL. So, fundamentally, get a different marker. Tasks are rather easy to use. You construct them giving any sort of invocable function object. You can so they're templatized, so you can give you can give a static function, a functor object, a lambda, anything like that. So basically, you construct a task, and let's say I had a simple task here that just does. Let's just do a hello world task. So if you're familiar with lambdas, you see I'm creating a function here, which takes nothing as a parameter and returns nothing. But then in here. Right, so you can stick anything inside a task. Now, when you create a task, they're scheduled immediately for execution, so you don't need to call start on them. And then they go through a life cycle of, they're scheduled, and at some point they'll be picked up and executed. And once you have a task, there's a couple different operations you can do on them. There's APIs for waiting on a task. You can schedule continuations on a task to do things like chaining. There's also some global APIs for doing operations with collections of tasks. So there are APIs like when all that take a vector of tasks. Joining together a group of tasks. There's also an API for when any, which is saying, when one of these completes, I want this task to execute. Also, there are overloads on the operators for accomplishing these as well. So you can do and this will take two tasks and join them. So this allows for rather quick combination of building up operations. Anyway, so all of our libraries in Casablanca, user-facing, they always deal with tasks. That's the fundamental unit of asynchrony in Casablanca. And yeah, so really if you get familiar with these, I think you'll really like our library offering.
I mentioned Stood Future. Why did we develop PPL tasks when futures seem to be doing the same thing?
Yes.
Well, the one issue with Stood Future in terms of asynchronous is that there is no .then, like Steve was showing for tasks. There is no way to hang on a continuation to a future. The only thing that you can do in order to collect their values from a future is to say .get, which blocks the current thread. So in other words, futures are about representing asynchronous operations, but not by chaining asynchronous operations. It turns an asynchronous operation into something you can wait on. And so we address that with PPL tasks. And that's why in a library where it's all about asynchronous and all about avoiding waits, we couldn't use the future for those purposes.
Well, that's interesting.
And I think when this brings up also a point when you're mentioning on the server side, particularly, let's take an HTTP server as an example. It could be processing a lot of requests. If you do something like synchronous I/O, where you're reading in the entity body of an HTTP request and block a thread, what happens if you have 100, 1,000 requests? Are you really going to block 1,000 threads? So, in all of our libraries, we're using, particularly in the Windows case, we're using overlapped I/O and completion ports on the thread pool. Mm-hmm. So, we're taking a lot of the work out of the way for the user. With our libraries, you're going to we're creating a server that will scale with the number of requests. We're not going to eat up resources or block threads whenever we're doing reading. And particularly sometimes that can be a challenging thing to program correctly. So having an API that's in modern C++ and also does those things is definitely very valuable.
Agreed. Because today, obviously, when you think about like ASP.NET running in IIS, it does a fairly good job of solving this problem, right? It doesn't eat up threads when you have 100,000 requests, right? Assuming you have enough servers to scale to the requests. So that's not. Technically, it's already been solved. But this is what brings up a good question. what am I going to want to play around with Casablanca? Now that it's available, I can write some C++ client talking to a custom C++ server. I have this nice asynchronous actor-based model. Yep. But tell me what you envision me doing as a native developer with this technology.
Yes. Well, so the first word I want to, the first caveat I want to come up with is mention is actually this is an incubation project. This is a DevLabs release. This is not something that you should go and put into a production system.
Yes.
That said, there's for example, we think that Win8 is a great future platform for interesting applications, right? That are connected applications. A trend over the last several years, to some extent pioneered by Apple and with the iPhone, etc., right, is this trend away from the browser as being the only interaction with sort of services for consumers and such, to the app model, the app plus internet model, where there are applications on the client that have a very rich experience, but the UI and the rich client experience is further enriched by the connectivity through wireless networks or 3G or 4G to services in the cloud. Mm-hmm. So one thing that we hope that native developers will play around with is developing with the new release of the Win8 consumer preview and the development tools for that. Take Casablanca, the Metro libraries, Metro-specific libraries in Casablanca, of the HTTP client and such, and try to write some native applications that connect to things like Bing Maps or Azure Storage or SkyDrive or whatever it may be, services that are there, or services that you have written yourself, right? The other thing that we hope that developers will play with is the service side. Like, you have some logic that you've had, some libraries, native libraries that you've had around for a while, and you want to see if you could stand up a service that uses these libraries. Maybe it's some technical computing type of workload that it really benefits from having native code for performance reasons. Maybe you can write a web service in native code around that exposes those computational capabilities to less powerful clients. Or take advantage of a centralized logic component for things like a multiplayer game or some sort of client experience that involves multiple parties without doing peer-to-peer communication. We also think, and we've talked about PPL and tasks and such in other contexts, but we also think that this is an excellent opportunity to experience PPL and PPL tasks, just because this is it goes beyond sort of the design of PPL tasks to be for computational purposes. Now we're bringing I/O to the table. Nice. And in fact, what PPL tasks offers, sort of the great promise there of this task model is that it is equally well suited for I/O as it is for computation. And in fact, a tremendous opportunity here for us and for developers is to use it to bring I/O and computation together. Like, you have heavy computation needs and you're I/O driven at the same time. You're doing both. And here's a model that can actually allow you to compose those two well and have them scheduled using underlying scheduling technology like Concert that can deal effectively with both types of works. So that's another aspect. And just get us feedback, get us thoughts on PPL, on HTTP client, on HTTP listener, the server-side stuff, and play around with actors too. It's maybe a little more advanced because it's really about server-side scalability. But the model works, just from a programming model perspective, it works in the small as well. So play around with actors. And DevLabs and this type of release is all about giving us feedback, telling us whether we're barking up the wrong tree, whether yes, this is a problem that we need solved, but you didn't go, we don't like the solution. Those types of constructive feedback is specifically what we're looking for with a release like that, which get things out early, get feedback, fix it, and come back with a even better solution the next time, right? And then you go around and iterate like that, for a little while, and you have something in the end that really addresses customer problems.
Absolutely. And in particular, right now, this would really be the time that you can have a lot of influence on, what sort of future investments we would make. What parts. We have a large, diverse set of libraries here. What would be most valuable to see in the future? What do you like? What do you not like? That sort of thing. Because Casablanca could end up impacting lots of different products in Microsoft. So
that's great. I mean, the other thing is everybody has learned everybody, but a fair number of people. I mean, the Bjarne interview's been watched over 100,000 times. So from Going Native, Herb talked about in his keynote the need for a more concerted effort in building general purpose libraries for C++. And to me, what I see here, which is very exciting, is wouldn't it be nice in a world where I didn't have to guess between 30 different implementations of a HTTP library, a JSON library, and there was this one great one that people got together and rallied around behind. And because you're building for broader platform scope, this could be the beginning of potential and offering in that space, and we'll see what people do in the real world.
Yeah.
But what are your thoughts on that? I mean, clearly this is packaged together as one.
Yeah. So this is not about building some proprietary Microsoft technology that will only be licensed and designed to work on Windows or other Microsoft platforms like the phone. This is about C++ and driving the C++ community forward, right? And making it just a richer experience. Herb talked exactly about the right issues. Like the class libraries for C++ are so tiny compared to what is available for other languages that it's not even funny, And we need to do something about this. And Casablanca absolutely fits into that. As let's get some experience with some important libraries right now. And let that experience feed into not just what Microsoft offers in terms of products, but in terms of what we can do in whether it's through standardization or open source or ways of getting these types of things. Once we think that they're mature enough and feel that they're actually good, right? We're not there yet. Get them out and make them wider than just Microsoft. This is not an effort for us to sort of design something that we're going to keep close to the chest, right? This is something that we really want everywhere, because that just makes it easier to leverage native code on any platform, which will involve also Microsoft platforms, obviously. So we're
great. That's awesome. So
build
high-performant server-side systems, build high-performant client-side systems, add them together with Casablanca. So beautiful, man. Let's see how it works in the real world.
Yep.
So download the stuff out there, people. You wanted more C++. Now you can actually grab it and play with it and provide feedback. So thank you guys for doing this project. I know people out there are going to be stoked.
And thank you, Charles, for letting us come and talk.
Letting you. I'm honored to meet you guys. And I see Steve a lot on the connector, man. Cheers, you guys.
Okay.
Thanks, Charles.
Bye.
All right. That was awesome. It's really, really nice, again, to reiterate, to see a movement towards more general purpose, very high level C++ libraries. The functionality that you learned about in Casablanca in the interview that we did, and when you download the code and read the documentation and provide feedback, you'll see that we're serious about this. And I think as an industry, we'll see more and more of this. So please download that, play around with the code, and give feedback to Nicholas and Steve and Artur and other people who are on it, Vikas as well, and make that stuff great. So we'll see you next time. Diego should be here. It's very odd doing this alone. Out.